Okay, welcome to the beginning of the Unit 3A test review. Let's go ahead and just jump on into it. The function h is graphed below. Find the period of h and evaluate h of 19. We need to know the period to be able to evaluate it. So there's a couple ways. Usually we would start at the y-axis, but you can see that doesn't cross at a good point, so I'm not going to do that. I'm going to start at this point here, right before it goes horizontal like this, and just trace until I get back to that start point. Okay, so that's a full cycle right there, highlighted in red. That is a gap. That is a gap of 9, so my period is 9. So to evaluate h of 19, because you can see the farthest my x-axis goes is to 12. To evaluate h of 19, I need to rewrite it as h of plus my period, and think like, how can I rewrite 19 as something plus my period? So 9 goes into 19 twice, and so this will be the same thing as h of 1. There's a remainder of 1, so that is the same thing as h of 1. And on the graph here, h of 1 is here at 3. So h of 19, 3. Similar problem here. The graph of g is periodic, where g of x plus 10 equals g of x. Remember, this is a horizontal shift. So this is saying if I shift by 10, really in either direction, if I start at any x value and I shift 10, it gives me the same output as the original x value. That means that my period, like this right here, is telling me about period equals 10. And it wants me to find g of 10. So let's go through this process here. Remember, we start with the innermost part here at g of 10. I'll do this in blue. Let's do g of 10. Obviously, that's not in my table, so I have to do something similar to this process right here and rewrite g of 10 as something. So g of my period is 10, so plus 10. And if I go forward from 10, I end up at 20. That's not on here, that's not helpful. But if I go backwards from 10 here, I end up at 0, which is a value on my chart. So I could rewrite this as 10 times negative 1 plus 0. So that is the same thing as g of 0, and g of 0 is 4. So now that 4 gets plugged back in here into the function composition. So g of 10 is the same thing as g of 4. And I've got to do the same exact process with g of 4 because it's not in my chart. If 4 was an x value given to me, I could just use that. But in this case, I need to rewrite this as g of plus 10. And looking at my options, once again, I'll see that I can multiply by negative 1. Multiply by 1, sorry, because I want to get to negative 6 here. And then add negative 6, because negative 6 plus 10 is 4. So this is the same thing as g of negative 6. Sorry for that little mistake there, which is 1. Okay, so to rewrite it fully too, you could rewrite it as g of 10 is 1. Okay. 3, the figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray, remember that's super important, of the angle intersects the circle at point S. So theta ends here at point S. The coordinates of P are 15, 8, and the radius of the circle is 17, and it wants to know the value of sine theta. So just quickly, to get the points of S, we can use circle symmetry and the symmetry of a circle. And really, with the symmetry of the circle, you can go ahead and use the behavior of the x and y coordinates in different quadrants. What do I mean by that? Well, remember, this is just going to be x, y. This will be negative x, y. This will be negative x, negative y in this quadrant. And here in this quadrant 4, you'll have x negative y. So if this is 15, 8, this is 15, negative 8. And a helpful visual reminder for my sine, cosine, and tangent. You can draw your triangle here. This is theta. This bottom direction here is x. This horizontal is my y. This is my radius of my circle. Like, this is my horizontal displacement, this is my vertical displacement, and this is my radius. This is just a helpful way for me to remember the ways that sine, cosine, and tangent relate to each other in this triangle. Because I know SOHCAHTOA. So, for example, sine of theta, SOHCAHTOA, is opposite over hypotenuse, rather. So that is y over r. Cosine of theta would be adjacent over hypotenuse, so x over r. And then tangent of theta is y over x. And sometimes we'll use it mainly later in this unit, but sine of theta over cosine theta. So I know all this, so I got to look at which one it wants me to use. It wants me to use sine of theta, so I'm going to go ahead and write this out. Sine of theta is y over r, and really I'm looking at the vertical displacement, or the y coordinate here at s, so that is negative 8 over, and my radius is 17, so negative 8 over 17.